Hi everyone, in this video we look at another example where we're asked to graph two cycles of the function y is equal to negative sine of negative 3x minus 180 degrees divided by 2 minus 1. So the first thing that we should do is there's quite a few transformations here that we have to apply, but it's always good when you're looking to make transformations. It's always good to ask yourself if you can algebraically simplify your equation so that you have to apply fewer transformations. So in this example, let's think about the graph of y is equal to sine of x. Here I've graphed y is equal to sine of x below. And now I want you to think about the graph of y is equal to negative sine of x. And ask yourself, how does this compare to the graph of y is equal to sine of negative x? So let's look at this. If I graph y is equal to negative sine of x, that's just a reflection about the x-axis. So we would have a point here, a point here. These points would all remain the same. And I'd have a point there and a point there. So I'm just reflecting all of the peaks about the x-axis. And that is the graph of y is equal to negative sine of x. Now let's think about the graph of y is equal to sine of negative x, where we reflect the graph about the y-axis. If we reflect this beige graph about the y-axis, this peak would reflect here. This point would stay here. This point would go here. Let's see here. This point would go there. This point would stay the same. This point would be mapped here. This point would be mapped here. This point would be mapped here. And we could, and this point would be mapped here. And this point would be mapped here. And this one would be mapped here. So you can see that if I draw a sinusoid through all these key points, I get the exact same graph as y is equal to negative sine of x. So here we can conclude that sine of negative x is equal to negative sine of x. Now, how is this is an identity, and how is this identity useful? Well, if in the example above, we have both a vertical reflection, or a reflection about the x-axis, and we have a reflection about the y-axis, that would essentially be reflecting about the, it's the same as reflecting about the y-axis twice, which is just going to bring us back to the same graph as y is equal to sine of x. So we can do a little bit of algebraic manipulation here, and we could say that this is equal to negative sine, and remember that here we have to factor, if we have a k-value, we have to make sure that that's factored out. The factor of a half here is already factored because this fraction bar is a grouping symbol. So we would divide negative 3x minus 180 degrees by negative 3. We're not going to divide it by a half or 2 because this fraction bar is already a grouping symbol. We would write this as negative sine of negative 3 over 2 times x plus 60 degrees minus 1. Now, we can use this identity below to say that this is equal to minus sine of all this, minus sign of all this would be, actually, let's actually write this out. We would have minus sine of 3/2 times x plus 60 degrees. Is there enough brackets there? I feel like there should be another bracket. Minus 1. Okay. 1, 2, 3 brackets. 1, 2, 3 closing brackets. There we go. So if I multiply negative sine of all this by minus 1, I would just get positive sine of 3/2 times x plus 60 degrees minus 1. And now I know I no longer need to apply any vertical or horizontal or any reflections about the y-axis or the x-axis. So that was the whole purpose to doing that. It's just a little bit of algebra to make graphing the function a lot easier. So next, let's think about what we need to do in order to graph this function, which is the same as graphing this function. In order to graph this equation, I first off let's figure out the amplitude. The a coefficient is 1, so the amplitude is going to be equal to 1. And there's no reflection about the x-axis or the y-axis, which is convenient for us. D is negative 60 degrees, so there's a phase shift. Phase shift of negative 60 degrees. C is negative 1. So we have our equation of the axis. Is y is equal to negative 1. And the period is going to be 360 degrees divided by k. K here is 3/2, so we have 360 degrees divided by 3 times 2. 360 degrees divided by 3 is 120. 120 times 2 is 240 degrees. So I think we've got all of the information that we need in order to graph this function. The next thing that we need to start thinking about is how are we going to scale everything. And what I always like to do is I always like to start by thinking about the vertical scale, and then I do the horizontal scaling after. So the equation of the axis is y is equal to negative 1, and the amplitude is 1, so that means we're going to have a minimum of negative 2 and a maximum of 0. So let's, just so that this looks a little bit nicer, let's scale this such that each grid space is a half unit. So that means that this this point would be, okay, like this is negative 1, this is negative 2, this is 1, and this is 2. There we go. The equation of the axis is just going to be the horizontal line drawn through the y is equal to negative 1. So it's y, the horizontal line y is equal to negative 1, which is this line. Okay, and of course we're going to have a maximum of 0 and a minimum of negative 2 because the amplitude is positive 1. So the next thing that we have to do is let's think about our scaling. We want to graph or our horizontal scaling rather. We've done the vertical scaling. We want to graph 2 cycles of a function that has a period of 240 degrees. So what that means is that I need to be able to fit 240 degrees this way, at least 240 degrees this way, and at least 240 degrees this way. So let's count how many units there are on each horizontal part of the axis. So this would be 1, 2, or sorry, grid spaces, I guess. This is 1 grid space, 2, 3, 4, 5, 6, 7, 8, 9. And then I would have 1, 2, 3, 4, 5, 6, 7, 8, 9 going this way. So if I scale this such that each grid space is 60 degrees, I should be able to fit 2 cycles on this grid. So let's say that this is 180 degrees, and this would be 360 degrees. This would be minus 180 degrees. This would be minus 360 degrees. And then 360 minus 180 degrees, or negative 360 minus 180 is negative 540. And this would be positive 540. Okay. So the next thing that I like to do when if I'm graphing a sinusoid is I think about where the initial point of that function maps to. So if you're graphing the cosine function, the first point that I always map is 0, 1, but since this is the sine function, I'm going to think about where the origin maps to, because the first key point of the sine function is 0, 0. So there is a vertical shift down 1 unit, because the equation of the axis is y is equal to negative 1. And then there's a phase shift of negative 60 degrees. So that means I'm going to shift 60 degrees to the left. So my first point is going to be negative 60 degrees, comma, negative 1. It's going to be right here. And there's no reflections here. So the next thing that we should do is we'll think about what one complete cycle is going to look like. The period is 240 degrees. So if I do 60 degrees plus its period, I should get a repeated y value after one complete cycle, right? Which is 240 degrees. So this is 60, 120, 180, 240 would be there. So now I can think about breaking this up into quarters. As you can see here, I've got 4 grid spaces on the horizontal axis between these two points. So the first point, if I break this up into quarters, the first quarter of my graph is going to be here. Then I'll have a point here. A point here, and that is one complete cycle. Oh, whoops. We're going to draw two cycles. I forgot. Okay. So that is one complete cycle. There we go. Now we can graph the second cycle this way, or we can just graph the second cycle this way. We're going to have another period after 4 grid spaces. So, or another complete cycle, 4 grid spaces to the left. So let's see here. This is minus 60 degrees, 180, or sorry, 60, 120, 180, and 240. So I'm going to go 240 degrees to the left on the grid. And again, I'm just going to break this up into quarters. This is the first quarter of the graph, the second quarter from this would be minus 240. From minus 240 to minus 180 is going to be the next quarter. And then we've got the next quarter here. So again, I'm breaking the cycle up into 4 quarters. Okay. And then I'll just sketch a smooth curve through those 4 quarters, or sorry, through those key points. Let me draw that again. And that is 2 cycles of the graph y is equal to negative sine of negative 3x minus 180 degrees over 2 minus 1. And as you can see, if we would have had to apply both of these reflections, the question would have been significantly more difficult. So by doing a little bit of algebra and knowing this identity here, it makes the work quite a bit easier. So we're going to stop there.